Hello, everybody, and welcome to today's webinar presentation, How to Get Fast Analytics from Your Data Wherever It Lives, brought to you by Starburst Data. I would like to introduce you to our presenter today, Randy Chertko. Randy is a solutions engineer at Starburst Data and has over 25 years of IT experience as an infrastructure architect for Fortune 500 companies. He has used his skills as a database developer, architect, and tools expert to implement enterprise scale IT at companies like Abbott Laboratories, VMware, Mesosphere, Cockroach Labs, and more. He has a master's in computer science with a data communications concentration in artificial intelligence. Besides his IT background, Randy is a musician on the side and has also written 4 books with major publishers about the music business. He has also professionally spoken all over the country at organizations like the Recording Academy and the City of New York at Carnegie Hall. And at this time, I'd like to pass it off to Randy for the presentation.
Thank you. Thanks for the introduction. I really appreciate it. Looking forward to talking with everybody today and to talk in particular about how to get fast analytics from your data wherever it lives. And as we were talking about, as you were mentioning in my background, I've dealt with this a lot as an infrastructure architect, not only in large enterprises, but with a lot of customers trying to solve their issues. So while you can have a very theoretical talk about this type of thing, my goal is to give you some practical ideas on how you can solve certain issues. And in particular, probably the most important one that's on nearly everybody's mind is how to get access to your data. Because most companies, once you grow, you end up with more data sources than you know what to do with. And very often when you try and get access to that data, it works something like this, where you have a question that you're trying to answer. Usually that question's not really bounded by any sort of idea about what data you'll need to answer it. And you end up trying to figure out, well, how can I get the data together in a way that I can actually do some analytics against it? In the Abbott Laboratories setup that I had that you mentioned about in my background, I actually had built one just to answer questions about our infrastructure. So we had about 16,000 servers and we had a network that spanned 140 countries. And inside that, we had a lot of information just about routers and switches and all of our servers, infrastructure information. There were a lot of questions that we were trying to answer. I think that by the time I left, by the time I was done there, I counted 25 different data sources I needed to do in order to answer some of these questions. And we usually went through the same process where I'd have to write an ETL in order to do it, which stands for extract, transform, and load. And nowadays, you actually sometimes have the option of putting the L before the T. So you extract it, you load it, and then you do some transforms against it. I had to do this by hand at the time. They didn't really give me any tools. I wish they had, but I was just fine with a script. But from there, you had to have a target. You had to have a place to land all this data, answer these questions. And in today's world, you can choose to put it in the cloud or on premise in data warehouses. And back at the time, we didn't really have data lakes. Now you have the ability to store raw files, usually in Parquet format or ORC format, in a way that's semi-queryable. It's semi-structured data. It's data on read. And once you've gone through all of this work, finally you can get an answer to the business. Now, usually when I was doing it, it was taking at least 24 to 48 hours. I'd have to go through a lot of work in order to get access to the data source and get it together. I see the same thing in other enterprises that I deal with very often. They go through this cycle. I had one group, which was a computer manufacturer out of the Midwest, and they would get requests for new data sources quite often. They'd wind up in this ETL cycle, and it took them, actually, I think that their SLA was 48 hours. Sometimes they had to do it overnight. Sometimes they had to do it on weekends. And finally, the business gets their answer at the other end of it. The thing about landing your data in a data warehouse and trying to get answers like this is that, well, first of all, it's slower than it looks. And by slower, there's actually two meanings to that. One is that it takes time to actually do the extract, transform, and load process. But the other, and this is actually what happened to this particular computer manufacturer, is that it only got extracted out of the data sources on a schedule. That schedule usually ran in the middle of the night, let's say 2 a.m. And one of the things they were looking to do was answer questions about how the inventory was doing that day. Imagine you're looking at a dashboard, and the dashboard is showing the inventory for the day. No matter how many times you refresh the dashboard, it shows the data from 2 in the morning. And when you look at the next day, it shows it from 2 in the morning, from the previous day's business, basically. So it's slower in terms of trying to get the data together, and it's slower in terms of how recent the data is basically what they're dealing with very often. They wanted real-time data. You also end up making a copy of the data. When you think copy, think cost. It actually costs more when you have more copies of the data on hand. You have to maintain it. Usually, as soon as you create 2 copies of the data, you always are trying to keep it synchronized, like we were talking about. It also limits your view to what's in the enterprise data warehouse right now. So your data is limited to what you have, and there's the next incremental data source that actually has the answer for what you're looking for. For example, just to give you an idea, right now we have census data that's coming out, and very often the census data is available, by the way, from the government for free, but a lot of people often enhance it with many other data sources and release it. So if you're trying to answer a question about your customers, there's, by the way, many enterprises that I deal with that have a customer 360 view, and their goal is to find out as much about their customers as possible. Census data is particularly useful for that. You can find people's locations, their demographics, quite a few useful things from a marketing standpoint, many things like that. Your data warehouse doesn't have that next incremental data source, and this is where the title of the talk comes from, trying to get to the data wherever it happens to live. There's also a vendor lock-in issue. Once you've put it in the data warehouse, you're stuck in it. It's especially a problem for cloud. I'll be talking about that in a little bit, but just to handle the scope of this issue, let's talk about the higher level picture of what we deal with. If you think about the questions that you're trying to answer and the data that you have, the data can be split into known and unknown data, and the same is true of the questions, where you have known questions, and sometimes you get into the unknown questions that later on you're discovering you need to answer. The KPIs that you have, the various dashboards that you might deal with are really living in the lower left corner in that foundational core segment. Again, this is from a Gartner paper called The Practical Logical Data Warehouse that was released in 2019. And in fact, they just recently did an update of it because it's such an important idea. It's when we start expanding into the unknowns that they really got going in the paper and started to talk about how do you deal with this type of issue. So an unknown question is, wait a minute, I just found out that my sales seem to fluctuate. I wonder if weather, for example, has an effect on my sales. And let's say you get a hold of weather data in order to do it. You need to merge together 2 data sources that you might not have had before. And that's where we start stretching the data from the known to the unknown, where we're trying to find out how to do it. The really exciting stuff happens in the upper right corner where you're doing innovation and exploration and not even worrying about what you have today and limiting your imagination to what is there. You can also do an overlay on top of this and really think about it in terms of the types of data sources that you currently have. Your real-time data warehouse usually lives in the lower left corner with known data and known questions, and sometimes it dips a little bit into some of the other quadrants. The traditional data warehouse, that's not the real time, but the traditional data warehouse gives you a slightly larger view because you're usually ingesting data as you go. Every time somebody asks questions and you're stretching into these new questions that you have and the data sets that you might not have incorporated yet. Like I said, the next incremental data source. Data lakes are very interesting. For those of you who might not have run into it, I like to call it a pile of files, and it's semi-structured data. It's usually in JSON format, in either Parquet or ORC format. And it's also called schema on read, which means that you can treat it as if it's a columnar data store and query it as if it's a database. And it's very useful for storing larger and larger amounts of data, especially when it's the same data over and over again. Like, let's say you have sales data and you actually have all of the sales data, or IoT data, like from devices. Just to give you another example, I was dealing with a major telecom provider the other day, and their data lake had data about all the calls they had. And since they're a major provider, the amount of call center calls they get is enormous, and it grows on a constant basis. That is not stored in a traditional data warehouse. That detailed data would be very expensive to keep there, and it's really best for a data lake. It's semi-structured, but the data is very regular. It has the same fields over and over again. So once we start to deal with this, the real issue that comes in is when we want to query it. When we actually get those next incremental questions, and we have a number of technologies that tend to come together in order to make all of this stuff work. For example, we have DBMSs that maybe are spread across all of our organizations. The interesting thing is, if you look back at your logical data warehouse, by now in the traditional and the real time, you've done some ETL work in order to pull the data together and try and answer it. Meanwhile, as I found out with this telecom provider, some of their data was in a SQL server. Other of the data was in, I believe it was Teradata or something like that. It was another major provider that they had other data, and they actually had questions that sometimes merged the data lake data, the data warehouse data, and the SQL server data all at the same time. And very often, like I said, there's many different tools we put together to do this, like Hadoop, maybe even non-relational data stores that have some of these types of things. All of these need to be queried, and sometimes the answer involves putting it all together in a way you can get it. Now, the way that we often have seen this happen, and I've seen this over and over again as I've dealt with large companies, is that the semi-structured and structured data get dumped into your single source of truth, as they call it, the data warehouse. And that's fine, except for all the issues that we talked about earlier, where we are facing basically trying to merge data from multiple places, the fact that your next incremental data source doesn't have it. The new way to handle this is to just create a single point of access. And in a lot of ways, the picture that you see here is lacking really a whole bunch of other icons that you can see beneath it, because your users, your BI analysts, sort of just want to have a single connection string. They want to treat it as if it's a data warehouse. They don't really want to worry about where it came from. In fact, in the ETLs, it sort of was hand delivered to them. What they actually might be running into is business asking a question with that next incremental data source going into those unknowns. And what you want to be able to do is add more data sources to the single point of access, being able to put all of it together. This model actually creates a lot of advantages. One of the key ones as an architect that I've dealt with very often is, as I'm putting together a system, you always want to think about the cost control that you're really trying to build into the whole thing, which is to say that you really want to be able to scale only the resources you need in order to put it together. Now, those of you who might have been dealing with data warehouses that you have, and especially the ones in the cloud, might realize that as soon as you try and scale it in terms of maybe adding more data into it or trying to get faster response from it, you usually have to scale both the storage as well as the compute, even though you only want one or the other. What you would prefer to do is just scaling down the compute when you need it if you're trying to do more queries, and leave the storage where it is. So the cost control that comes out of that means that you can actually only have the number of worker nodes running in order to access everything, leave the data where it is, and even scale down so that your operational costs go down. Another is the vendor lock-in, and the cloud data warehouses that we were talking about earlier. I've seen this very often where they've done cost calculations on just extracting the data just to get it out if they want to migrate the data out. And the costs are sometimes 5 or even 6 figures in terms of the network costs as well as everything else in order to do a migration. It's not just a question of the file formats that we were talking about, which is ORC or Parquet. The columnar database is performing better. You really want to make it so that this entire system is flexible. And speaking of flexible, you want to be able to not worry about where the data is located. So let's say your data is in a data warehouse and you decide that you want to move it to a different data warehouse, or let's say you have one of those DBMSs that has just a chunk of your data and you decide, we don't need this anymore. After you move the data, all of your analysts then need to deal with trying to get a hold of it. You need to tell them where it's been moved to. You have to deal with change management. You might have to do an ETL if you're just trying to put everything into a data warehouse. What you can do with a system like a single point of access is you can define what's called a semantic view. And the semantic view specifies where the data is located, but to the user, it acts in every way as if it's just a single table. And they don't actually have to care about the location of each of the tables. So for example, you might have one table that's in the data lake, another one that's in the data warehouse, a third one that's in a SQL server or a DBMS of some sort. And if you decide to move any one of them, all you have to do is change that definition. So we've actually helped many companies deal with this kind of migration issue. And if you've got a migration on your mind, this abstraction from the data allows you to have a choice. In fact, the abstraction gives you a lot of advantages in that you can impute global security on top of multiple data sources. And it's something that we run into in healthcare, we run into it in fintech, we run into it in many other types of companies that have strict requirements where they might be audited afterwards. So from a query auditing and masking standpoint, masking, if you haven't run into it, is if you have PII data and you only want to show, let's say, the last 3 digits of a social security number, but you still want to do a join on the real social security number. What you can do is actually make a change only at the access point and leave the raw data the way it is. You can even define security in terms of fine-grained access control on a column or even row level permission for each of the data sources. So on a per user basis, you can decide what they see and what they don't. And in today's world with the recent California Act, we actually have many companies asking, can I decide on a per user basis what they see? Again, this access layer allows you to do this kind of thing. And in fact, it allows you to do even more than that, because first of all, from your user standpoint, you don't know what tools they're using. I've seen analysts come in from the street saying, this is the tool that I use, and companies going out of their way for a high-powered analyst, especially a data scientist, to use what they need to. They need a connection string that gets to all the data sources, which, if, as stated before, although you could do that in a data warehouse, every time they ask for something new, you need to bring it in. Instead, the way that this access layer works out for you is that in Starburst at least, there's over 50 different connector types. So all the logos you see at the bottom are fair game. You can connect it to the data warehouse. You can merge data together in order to bring it together for your users, and your users are just accessing it as if it's one single place. The nice thing about this is it makes auditing very easy because you can see everything that people are accessing, when, and if you need to, how long it takes, so that you can do query tuning, which is one reason why we see people wanting to do this. It is surprising at how many tools that start to get into this don't have persistence. I was just talking to a company the other day that was using an access layer of a sort, but it disappeared after they restarted the cluster, so they couldn't find out, well, what did they run last week? which from an auditing standpoint, from an outside agency type of standpoint, really gave them a lot of problems. They were in the fintech space. This type of architecture is flexible enough to do many different types of things. So let me talk about the types of places where people start to get involved in this type of thing, just to give you ideas on what you can architect using this layer, this access layer. One that we see very often is doing faster analytics against a data lake. So as stated before, you can think of it as a pile of files that are semi-structured. There's schema on read, which means that you can get access to it as long as you have an imputed schema that you can dig out of the files. The issues with this is that once you bring data out of a DBMS, you lose all of the caching. And the ways that we've dealt with this previously, when you look at Hadoop clusters, for example, which are in front of something like an HDFS, or maybe you have S3 if you're in the cloud, or a DLS if you're in Azure, or I can keep going, or because there's a lot of places to store files, is that they end up using something like Hive or Impala. The thing about those systems is that they actually have scaling issues, and it takes them a remarkable amount of time to pull the data in and to be able to query it. Just to give you an idea, we were at one insurance company and we ran a query that they asked us to do a test for. After we brought in the system, we installed it, we connected it up to their data lake, and the response that we got back was something more than an hour. It might have even been more than 2 hours for a particular query when they ran it using Hive. We ran it using Starburst, and the way that Starburst works, by the way, is it highly parallelizes this by grabbing each file separately from all the worker nodes, which means that, as we talked about, if you scale your compute, you reduce the amount of time it takes to get the answer back. You drop the latency down. And so we ran the query in minutes. It was well under 10 minutes. It might have even just been a couple minutes. And they looked at, it was one of my colleagues that did this. They looked at my colleague and said, "You must be cheating." He's like, "What are you talking about?" He's like, "You don't understand. This query can take hours." And in fact, I just experienced this myself. I think it was at that same cell phone provider that I was talking about earlier, where they had a query that took 2 hours that actually got boiled down to just 7 to 9 minutes on average. So we see this as being a place where people often use this single point of access. And what ends up happening shortly after that is that you start to get into those unknown quadrants we were talking about earlier. And you're trying to answer more questions with data sources that are not yet available to the data warehouse that they have. And you want to join another data source in with the whole thing. So what I ran into actually this one is at a computer manufacturer in the Midwest, where they started by connecting, I think it was 5 different data sources, and it was quite a variety of data sources too. They were connecting a on-prem data lake, I think it was an HDFS. They had some form of DBMS. They had a NoSQL database. I think it was Mongo in this case. And I think they had a couple other DBMSs, random ones. So there's about 5 data sources they have. Almost immediately after they did it, they got to that incremental data source issue that we talked about earlier with the unknown data, well, unknown when you first started, and the new questions that were coming out. So before long, they had 9 data sources. Between calls, when we talked to them, they went from 5 to 9 because all they had to do was add a connection string to these new data sources, and suddenly it was available to people as part of a new catalog. So this really helped quite a bit and allowed them to expand what they're getting into. I haven't talked to them in a couple months, I think. I'll have to check with them. As far as I know, they have something in the teens in terms of number of new data sources and even more that they want to do. Naturally, once you do that, that's when you have to scale your compute a little more to handle it. And although you have to do that, you actually reduce the unnecessary data movement. So what they ended up doing actually at this particular place, this is the one that had ETLs that they were doing within 24 hours or 48 hours. They actually stopped moving the data around, left it where it was, and they reduced the data warehouse costs because they didn't have the extra copies. They weren't dealing with any issues along those lines. And The real flexibility that they had was to take things as they come. I think that there was a joke by Stephen Wright from a long time ago, and he always delivered these one-liner jokes. His one-liner joke was, you can't have everything, where would you put it? And my answer is, if I have everything, why don't I just leave it where it is and pick it up wherever I find it? Which is exactly what you can do once you have an access layer. Leave your data where it is, pick it up when you need it, and you're good. There's another use case that we see very often, and that's about migrating data without analytics and interruption. So we talked about this a little bit earlier. If you have a semantic view of the data, then what that actually means to people is that as you are using this in tools like Tableau, which actually expect to see a single table and allow you to put it together, you can present a table view that actually might come from 3 or 4 different data sources. It's very easy to do this. It's very easy to change it. And it's straightforward as you're going to put this together. So one of the bigger things that comes together with this whole thing is to really think of it in terms of, I've got data, I don't know where the next data that I need is going to come from. I'm not sure what questions they are that are going to ask, but if I create the right kind of access layer, I don't need to worry about these things ahead of time because my architecture, my tools in my architecture can handle the upcoming questions and deal with things very well. The future proofing that we were talking about has to come from the actual tools and architecture that you have. Dealing with all the different data sources that you might have to handle, as we talked about earlier, might come up to many different types of things. But if the access layer can handle it, again, you have a lot of flexibility. If you're migrating to the cloud, you can move things and not have to deal with a lot of change management with your end users. We have many real life examples of these types of things that of very large companies that we deal with. It's part of my biggest joys as I deal with it is because I came from inside of large enterprises. I love helping other large enterprises achieve not just the vision of what they have in front of them, but going forward. So for example, with Tesla, they achieved GDPR compliance by leaving data where it lives locally, and they kept the data in the countries that it came from while being able to query all of it, which is actually, according to the law, you can do it. Even if you have backups, they're actually concerned about this. With an access layer, you don't need to deal with this. They also actually were able to reduce their EC2 usage and get a much faster response. And you know how we did that, as we talked about earlier. It's about highly parallelizing all of the worker nodes to be able to do it. Slack achieved much better uptime and was able to achieve much better performance than some of the cloud versions of data virtualization or access points, including reducing their TCO. With Zalando, you actually streamline their workflow and of course save costs. And one of my favorites is the Bank of America, where you just started to eliminate the ETL for joining Oracle, HDFS, and many others. And they just replaced out their entire Spark Impala architecture. There's one more type of real life example that you should think about that often comes up, which is that sometimes you want your data warehouse, and it really comes from what we talked about near the beginning, where you want your data warehouse to really have the real-time data that's available to it. But you might have good need for the archive data. Now, I was in a company that was regulated by the FDA at Abbott Laboratories. It's health sciences. You need to keep data for a minimum of 7 years for many of their requirements, but you don't really need to keep all 7 years in a real-time data warehouse. That said, you still need to be able to query the data. So here's how you could save costs with something like this. You put all of that extra data in the data lake, maybe only keep 5 years on hand in your real-time data warehouse. And because it's in the data lake, it becomes, with this access layer, within query reach of anybody trying to run queries against it. Among the things I haven't talked about, because it's another double click beyond that, maybe we'll talk about it in some future talk, is some of the other functionalities that we have that help with this. So data lake being a pile of files, it helps to have a cache. We actually have the ability to put a cache in front of that so that as you query it more often, you get responses much more quickly without having to go back to those raw files over and over again. Similarly, when you add something like a traditional DBMS, the DBMS might be fine, but it might also be used for transactional purposes, and you might not want to create too much load against it when people are writing their queries. We've all seen some of these BI tools actually go after some of these types of things and write very bad queries. Among the things that we can do is schedule a data pull so that we can redirect the tables to a cache instead of going against the original data source. And so what that ends up doing for us, which is pretty exciting, is that it means that we protect it. Maybe we'll go after it every hour or every 10 minutes, but we're still pulling very recent data, and therefore the dashboards are actually up to date. You have near real-time data without all of the extra load. So all of these things are examples of what we've seen, and hopefully it gives you some ideas about how you can use an architecture like this to achieve a logical data warehouse and a single access point for all of your data, no matter where it lives. I'd like to thank you for having us today and open it up for questions. For this, I'd like to introduce Mandy from Starburst. She's one of my colleagues, and I think she's done the work of collecting the questions from anybody who has any.
Yes, thank you, Randy. Randy, that was wonderful. Definitely a topic that I think with all of the access we have to so many different data storages, data points, having that fast access no matter where it lives is a really great topic. And building off that, I think a lot of people joining the webinar, this is their first time hearing about Starburst. So one of the questions I have are if you could go over the 3 main benefits of Starburst Enterprise.
Oh yeah, thanks for asking. And it's something that I probably should have mentioned earlier. Starburst Trino, as we call it, it used to be called Presto, it is now called Trino, is source available and is open source therefore, and you can download and install and use it. And there's a number of advances that we've made in the Enterprise Edition that you really need to see. Some of the ones I'd put in the top 3 are: number 1, it's faster. It shouldn't surprise you that pretty much anybody in the data space are speed demons and are always trying to get faster and faster access to the data that you'd expect. Among the things that we've done are parallelizing things even more to some of the data sources. Some of them, in fact, are single-threaded in the non-enterprise version, and so that's a big deal. Some of the global security that you were seeing is another one where we've enhanced it with the ability to do role-based access control, data masking, and tying it to your LDAP backend, which, as I've dealt with in the last year implementing this, that's always a big factor. People want to use the existing groups and everything else they have. And finally, and probably most importantly, we're here to support you with an enterprise edition. So we often have people asking us, how do we architect it? How do we future-proof it? How do we support it when there's questions? We've added a lot of install niceties that you don't have in the regular non-enterprise version. So we've made it more HA. We've made it a lot more robust in terms of what enterprises require, and we support that as well. So all of these things turn out to be very useful, and companies that work with us tend to be really happy about the end result.
Great, and I got another question coming in. Building off of that, how difficult or easy is it to implement Starburst into your organization?
Oh yeah, that's another thing that I run into. In fact, just to give you an idea, as I talk to some companies about it, and we have our ongoing conversations that start from the first call where we talk about, hey, here's what a single point of access can do for you. I've had some of them implement it themselves in their own labs. So like in between calls, I'm like, okay, would you like to see a demo? They're like, nope, I've already implemented it. I've already got it connected to 3 or 4 of the data sources. The documentation is out there. It's pretty easy to just try out and play with. As far as the Enterprise Edition, we're happy to work with people who want to actually try it in their real environment with the enhanced security, with the much faster access that they get. And so it becomes really straightforward to do this. The types of things you need to do in order to connect up a data source starts with just having the connection string, just like you would have it inside of any of your query tools, and the user credentials that you would use. That's actually a minimal configuration, and it's often enough to get it started and connected up. There's a little bit of tuning you can do, but it's very straightforward to try out and to implement. And very often our installs take a pretty short amount of time in environments that have everything ready to go, like those connection criteria. Most of the time I've actually had slowdowns, interestingly, is not from the technology. It's because we talk to a group and they're like, oh, we need to get some credentials. We have to go through a committee, get those credentials to you. Once the credentials are there, we just add the data source and it goes forward. So it's very easy to play with and check out.
Awesome. Okay, it looks like I have one more question. Does Starburst completely eliminate the need for ETL, the extract, transform, and load you were talking about earlier?
That is an excellent question, and we run into that quite a lot. The key in that acronym is the T part. It's the transform part of it. So we actually can extract data, and while we don't load it, we can present it to the users as if it's a single data warehouse. That makes it unnecessary to load it somewhere else and actually make a duplicate. The transform part can be something that your organization needs to do if your data is, as we like to call it, very dirty. Like let's say you have data with many different versions of the same thing. I often like to use an example. If you had 3 stores that are part of you have like 3 stores that you own and you want to do reporting from it, and let's say one store calls it umbrella, another store sells it but it's umbrella, and the third one uses a third different name. You sometimes need to clean up the data a little bit. We do have methods to do it using UDFs rather, user-defined functions, and using other SQL-based mechanisms in order to normalize some of the data. There's other fact tables that you can do. You can have lookup tables. Some of the cleanup might be necessary, and so it doesn't tend to completely eliminate all ETL if you have a very, very complex environment. But here's what we see. If I can go back to this slide right here, you would end up ETLing it into your real-time data warehouse. That's where some of the cleanup happens. As the data gets older, as we talked about, you can move it into the data lake after it's already been cleaned up. You can handle the extraneous data sources with a little bit of the UDFs and with some of the SQL statements that you can use to basically normalize the data. In between each of this, it actually comes together very nicely. So you tend to have a core backbone of a data warehouse that has the key data that they need, and yet the part that gets missing that we handle is, as stated, the unknown questions and unknown data. So you can live in these squares while actually continuing to meet the needs of your organization if some of your initial data sources might not have the cleanest data to deal with. So these things are things that you need to handle one way or the other and work around. And the great news is there's lots of tools to do it while fitting it into the broader picture of meeting the needs of your organization and analytics.
Awesome. That clears that up for that question. I think that was the last question we had come in. So thank you so much, Randy. Are people able to see your contact information to reach out for any additional questions that we weren't able to get to?
I believe we can make sure that that's available in the notes afterwards. And
Perfect.
thank you to DZone. Can you make sure that that's in there if you don't mind? And thanks for having us.
Yes, we will absolutely make sure to include your contact information with the recording of the webinar and put it in the notes for the audience to have as well. And with that, I would like to thank you, Randy, for your phenomenal presentation. DZone would also like to thank Starburst Data for providing our audience with a great webinar. Lastly, thank you to everyone who attended today. We hope we learned something new that will help you in your developer career. Have a great day.